So once again, good evening, everyone. So
Yeah,
tonight,
good evening.
we'll be talking about Python exceptions. And as usual, when we learn about a concept, the first thing that should come to our mind is what exactly is this concept, or what does it mean, or why do I need it? So I might start asking questions: why and how? How can I actually use this so-called concept? So basically, tonight we'll be discussing about these questions about what exceptions are and why it is needed that we understand such a concept. So basically, to begin with, when we are talking about exceptions, it's just a part of an error. Because when we say errors in our program, we have two types. It's either the errors are
Okay,
compile.
syntax error or runtime error.
Exactly,
Syntax error or runtime error.
exactly.
Uh,
And
so
syntax error.
exceptions are basically runtime error should be.
Yes, exceptions are runtime errors. That is errors that we
That's the
encounter.
exception that it is now runtime error. Okay, okay.
Yes,
Enter as when it's
they are
running,
errors we
program is
encounter
running.
when we are running
Okay,
our
okay, okay.
program.
I get it here.
Unlike
Okay, I
languages
get it
that,
here.
if they are errors, they won't even compile. An example is C. Maybe you miss a semicolon in your file, your program. When you try to GCC the file, you will likely get an error. It will not even run. Talk less of it crashing while it's actually running. But for errors like, I'm talking in terms of C now, errors like segmentation fault error. If you GCC your file, it is going to compile, even though you have a segmentation fault somewhere in your program. But at some point, the segmentation fault will likely crash your program. So that one we can refer to it as runtime error. But the semicolon that you missed in your file, that one we can refer to that one as syntax error. That will not even allow your program to compile, talk less of it running. So, but tonight, we are basically talking about runtime errors. That is, they are not errors that will not make our program to run. Our program will start executing. You remember that Python is an interpreted language, so it interprets line by line. So at some point in your program, it is possible that there might be an error somewhere in your program. And obviously, errors can potentially crash or terminate your program. So therefore, how can we manage these errors? That is what we are just discussing tonight. And that's where this concept exception comes in. In other words, exception means errors that are being encountered when we are running our program. So it is those errors that we will be talking about tonight. There are some errors that are anticipated, that we can likely anticipate them. Okay, this error can likely happen, or, well, this is not the way I intended for my program to run, but somehow the end user can use it in a way other than it is intended for it to be used. So therefore, you have to account for errors so that you will not write a code that in the real sense doesn't have a bug, but at the time of the end user using the code or using your program, then your employer will tell you your code has bugs because you didn't make allowances for errors that might likely, pop up as at the point of the
Okay,
user using the program.
how do you actually do that with C? That's another thing I'm wondering. There you can handle errors in JavaScript. You can handle sorry, you can handle exceptions in JavaScript. You can
Yeah.
handle exceptions in Java. You can handle with try catch, final or final. Then you can also handle exceptions in Python with try except.
Yes.
How do you handle exceptions in C? You know, I've tried browsing that in it was
For
like
me
I did
personally,
not see any way to handle it. I
yeah,
don't know.
I don't think C has any built-in syntax to handle runtime errors. I don't think so. You just have to think outside the box and try to think as the end user of such a program in such a way that you would try to anticipate the possible ways the program can be used. But of course, you may not readily know all the possible ways in which the program can be used. But you can, put limits to your program. For instance, someone who is trying to write a program that should require an argument, you can use your AC, argument count. You can use that one to check, okay, if the user is running this program without supplying the necessary arguments, maybe at least it requires 2 arguments, and then the user is entering just a single argument, then you can use that AC. You can use your if else conditional statements. That one you can use it to control or prevent errors that might likely occur. But maybe you can't actually anticipate all errors, but at least you can limit them to the barest minimum. I believe for C, you can at least limit them depending on how vast you are and how experienced you are with possible ways in which your end user can use your program. But in terms of Python now, these errors, they are actually numerous. There are a lot of them. We can't discuss about all of them tonight. It's not possible, but we just pick maybe one or two of them and we just discuss about the errors. So basically we have two types of errors. We have errors referred to as built-in errors, and we also have errors that we can refer to as custom errors or user defined. That is, you yourself, you create your own error. But we have some errors too that are already built in into this interpreter you are looking at. I believe you can see the interpreter I have displayed on my screen. So we have some errors that are built in here. So when you actually type in something that is, should I say, wrong, then this error will pop up as at the time of it being interpreted, that is your program running. And these errors can be grouped into different groups. You understand that these errors, the master class of all errors, we refer to it as base exception. Now we stop using the word errors. I will start using the word exception now. If you remember, I said exceptions are runtime errors, right? So when I say exceptions, you still know I'm referring to errors, but I'm very, very specific now. I'm not talking about compile time errors. I'm now being specific and narrowing it down to runtime errors. So the master class of all exceptions is the base exception. Now the base exception, you don't want to actually tamper with that guy. Should I say it's a type of exception you do not want to actually get your hands dirty with, because it can crash your program and you can do some things or potentially touch stuff you do not need to touch, because the type of error that base exception is handling are errors you will likely not need. They are errors related to the operating system, and why do you need to start touching errors that are very, very closely related to the operating system of your own computer? So I'm just saying, like, a master class of all errors you can possibly have, like all built-in errors in Python, is being managed by this base exception. Then we now have other exceptions that are like subclasses to this particular base exception, which we refer to as the master exception. There are a lot of them. We have the, let me see, I'm coming, let me check the classes. I know we have the arithmetic. Then we also have
arithmetic exception, type exception, type.
The arithmetic exception. There are a lot of them under it. We have the zero division, the type. No, we have value, I believe, zero division error, and some other type of
value. Value is it value of the type? Is it the value exception?
Yeah, there's value error.
Type exception. I thought that.
Then okay, yeah, I've seen it. Under arithmetic, we have floating points, we have overflow, we have zero division. Then another exception we have is assertion error, attribute error, buffer error, end of file error, import error, module not found error, lookup error. We can keep on listing them on and on like that. There are a lot of them, actually, a lot of errors. But all of these errors, like I said, are being managed by the base exception error, which is like the master class. And when you have errors that are under a particular error, like we say arithmetic error is under the base exception, it is going to actually get some of the attributes of this base exception, because it's like a subclass to the class or the master class called base exception. So it is going to get some of the attributes of this base exception. Don't worry, when we create our own exception, you are going to understand what we mean by it being inheriting the exceptions of the built-in exceptions that we inheriting properties of the built-in exceptions that we have. So we have some keywords that we use. Let me just show us some types of possible errors we can actually see, just so we show it practically. the errors that we can likely experience when we are running an interpreted language like Python. For instance, let me just type in something here. Let's say I want to do something like 20 divided by 5. Let's say I'm trying to type something like this. Of course, we know it is going to work, right? It's giving me 4. Now let me say something like 20 divided by 0. Then even from normal mathematics, this is not possible because you cannot actually have 0 here as the denominator and have, in fact, anything 0 as the denominator is actually wrong. You can't do this in normal mathematics. So it has been added to Python 2 as well in such a way that it's going to throw an error, and this is the error here. They call it the zero division error. We are still going to show an example with this. We are going to, when we are trying to explain the keywords that we use in Python for this, then I will use this as an example using the zero division error. Not only this guy, we have other errors too that we can see. For instance, let's say I typed in something that is wrong. Maybe I want to say wow true, then I actually forgot to put the E, so I wrote something like WHIL, wow, then true, something like this, and I want to press enter. Then it's going to throw an error that no, something is wrong here. You can see this is another error, that is an exception called what? Syntax error. If you are not using the proper syntax that is required by Python, then you are going to get an error. Let's say I want to do something like, we can concatenate strings, right? I want to add maybe 2 plus 2. Of course, I'm expecting it to be added because this is a string, right? Then let's say I want to add a string with an integer. Then I can't concatenate an integer value, right? Or maybe a floating point value. So when I do something like this, another error is going to come up, which is, this error now is called type error. It is different from this one, and it is even different from this one. So you can see there are different errors that are very specific, and their naming convention, if you can check very well, it follows a pattern. You can see 0 in caps, division in caps, E in caps, S in caps, E in caps,
That's
C in caps, E
camel
in caps.
case. Camel case.
Camel casing. Okay.
Camel casing. Okay.
Is that camel casing? I think camel casing should be something like maybe starting with small letter, then in between capital letter.
Small.
Huh?
Yes. The following strings, the following words will start with uppercase.
Okay. But the first one is starting with lowercase. Okay. Yeah. So basically, we have different.
But that's not the case here.
That's
not the case here. This one.
Yeah, this one is another type of naming convention. I think this is the normal, maybe the normal one or something. I'm not sure. I don't know. I can't remember this naming convention.
What's the name of this naming convention?
Yeah, that's what I said. I don't know right now. I don't know. But the key thing to note here is that the error is always starting with E, and whatever is starting it to, it's always starting with capital letter, all caps, uppercase. Then, like, there are words that are joined together. Zero division. 0 is starting with uppercase. Division as another word is starting with uppercase. Then error, which is another word, is also starting with uppercase. On and on. Then another one is name error. For instance, when I decide to just say print A, obviously there's nothing like A in my program because I've not defined it. And when I type enter, then it's going to throw an error that come on, what is A? You can see it's saying that what? Name error, and it is giving me this error message that A is actually not defined in my program. So we've been able to see that there are different type of errors that we can likely see in our program. Another one we'll talk about is module not found error. We are trying to import a module that is actually not existing. It is going to throw an error that this module is not found. For instance, if I say something like let's just say from CodeTrybe import quote 15, quote 13, then obviously there's nothing like CodeTrybe defined in my interpreter and quote 13. But let's just try to do something like this. You can see it is telling me that it can't find this module that I want to import, which is CodeTrybe. It's telling me it can't be found. So a lot of errors, different errors that are very unique or specific to whatever is happening on the as your interpreter is interpreting it. The specific error that it gets, it is going to tell you those errors. Now, why do we actually need to know about these errors? Like I said, errors will potentially crash your program. Like when an error is encountered, for instance, let me show that here. Let's say we have let's just say we have something like something that can potentially crash my program. Okay, let's say I want to do for a in no, let me use the for keyword. Let me say I want to do dev sum, then a, then I'm now saying something like return a plus b, something like this. Then I'm calling sum and this work, and I'm passing to. Now it's saying it's throwing an error. In fact, let me edit this thing in such a way that it is going to print out okay, the point here is that this program actually crashed. It terminated, like it crashed, because on encountering this name error, the execution of the program wasn't successful, obviously, because there is nothing like b, or I didn't define b in my program. So when you encounter errors in your script, then your program can potentially crash. So to avoid this type of crash, that is where error handling comes in. That is when you try to have like a clue of how to handle these errors and how to use them to your own advantage. So I'm going to make a directory now, call it cohort 15. So I'm going to enter into the directory cohort 15. Okay. So I'm going to create a file, and we're just going to quickly, let me name it exception.py. Yeah, let me create a file called exception.py. So there are some keywords that we use to actually undo errors or exceptions. So there are two things you can do as regards exceptions. There's something called you catching exceptions, and there's something called we raising up exceptions. So those are two things there. We are going to discuss them one after the other. The first thing is we catching exceptions, and another thing is you raising them. First and foremost, let us discuss about what it means to catch exceptions. That's the first thing we are going to discuss. When we are talking about catching exceptions, it means that as at the time of you running your script and your program, you will anticipate that, okay, it's likely my end user is not using this program the way I want them to use it. So you can actually catch an exception. That is, you can catch an error that can likely occur. So there are specific keywords that we use to do that when you want to catch errors in your program. That is runtime errors in your program. We have about 5 of them, I believe. So we'll be discussing about them one after the other. These particular keywords that can be used to catch exception. We are talking about catching now. We are going to discuss about raising later. So the first one, or should I say the most common one, are two words. They call it the try and except. These are words I think they occur in pair. So you can just try except, and we'll be discussing about what these particular keywords, what they mean. When we say try, English word or try like this. Let me increase the font. Good. So when we say try, a try block, as it is usually being called, would normally consist of the code you want to run. That is, what you want to do. For instance, the other time we saw the error that has to do with zero division error. That is someone that wants to divide, let's say 20 divided by 0 or anything divided by 0. That is not possible. Mathematically, it's not possible. And whenever you are trying to do such a thing in your script now as well, it is also going to bring out that kind of error. So let's say you are asking the user to, okay, you want to you want to divide two numbers, the numerator and the denominator, and the user is entering a value for the denominator as 0. That can potentially crash your program. Obviously, you know that is going to happen. But by the time you use the try keyword you input inside the try block the program that you feel that you know can be potentially crashed if an error occurs, or if the user doesn't use it the way you intended them to use it. So if the error did eventually occur, then you can use your except keyword to prevent your total program from being terminated. That is, the except keyword, it is going to catch that error. This is where the word catching comes from. Using the except keyword, you are going to use that to catch your error, and your program won't terminate. Let me just type it out here. So we have the try keyword, we have the except, we also have another one called else, we have finally, and the last one, which is raise. These three guys, try, except, else, finally, we can use them to catch exceptions, that is runtime errors. We can use those keywords. But when we are talking about raising, then this particular keyword, raise itself, is what is directly connected with raising exceptions. So like I was saying, we'll be using the instance of zero division error to illustrate how to use these keywords or how they function. So let us try to start writing a very basic program using the try keyword. I'm just going to say try, and of course we know.
Are we going to use all of them? The except, else, finally, raise. Are we going to use all of them?
Yeah, but we are going to be doing it bit by bit actually. So we are trying first and foremost.
Please, and then so that we cover it.
You said?
So that we'll cover it too. It's better we cover everything. We don't leave anything out.
Yes.
We cover the except, we cover the else, we cover the final, we cover the raise.
We are going to talk about everything. Yeah. We are going to talk about everything. So this is me writing a program now. Like I said, your try block will always contain what you want to try out. That is what you know can potentially crash. That's what you are going to put in here. So I'm going to use the try keyword, then on another line I'm going to indent it. In fact, it's even automatic indentation. We already know that Python is like strictly indented language. So after using this try keyword, you are going to input here your code block, the block code block that you want to try out. So what do you want to try? Let us try to get inputs from the user. Maybe the user is going to enter a value that we don't know. So let's say we have value1, let me say value underscore 1 equals to, then I'm going to use my input. So I'm going to say int, I'm going to typecast that to an integer value, input, then this input is used to get read from your standard input, right, from your keyboard. So I can say something like enter a number, or let me say enter the numerator. Let me say something like that, enter there. So we can specify the numerator, then I'm going to add a space there. Yeah, then my second closing curly braces, then I can say value 2. In fact, let me name this guy numerator, not value 2, numerator, just to make it even more explanatory. Then let me say this guy is my denominator, and I'm going to say equals to what, int. I'm typecasting it to an int. We know input by default is going to store it as a string, right? So that's basically what I'm just trying to do there. Enter your words, enter the denominator, something like this. Okay, Then basically what this code is trying to do is it wants to why is it giving me indentation here? This code wants to, okay, I didn't close that. This code will try to divide your numerator divided by your denominator. So it is going to say division result equals to, then it's going to say numerator over the denominator over the denominator. Then let us try to print out our, let's say, result. Let me use f string. So let's say result, that is the this divided by this is what. So I'll just print out my division result. So I should terminate this here. No. Yeah, I think something like this. If I'm not wrong, my f string result, then division result, which is this guy. Okay. So now
that's okay. There's something like that.
so let us try to run this program now, just to show us what will likely happen. So I just saved that. Let me see. Oh, what's this being displayed on my screen? Okay, we have a file call. So I want to run Python 3, then exception py. It says that what? Unexpected end of file. Why passing? Line 13.
See, I don't know. You did not include the shebang. This module now, there's no shebang.
No.
It started with comments. It not put.
I don't think
Not
that
shebang.
should be.
I don't know that that's a problem.
I'm not so sure, but then let me try to put the except. Wait, did I use the f string, opening quotes, closing quotes, this guy and this guy? Okay, let me use the except keyword then. Let's catch this guy, but I wanted it to actually crash. So when we are using the except keyword, we specify the type of error we want it to catch. You might likely anticipate, okay, the user might enter maybe 0 here or whatever, and the user might even enter something not an integer value, because you are typecasting it to an int. Let's say the user is entering ABCD and it's way different from 1 2 3 4 numeric values you are expecting. So anything can actually happen. You don't know, you can't say. So you might want to catch maybe the possible number of errors that might likely occur when you are trying to write something of this nature. But for now, let's just catch this error that we saw earlier about the zero division error. So you would write it manually, zero division error, then you put your semicolon. Then when you catch this, you can say except zero division error. Then you can decide to print out something to the screen that, okay, sorry, enter a number greater than 0, or anything. You can just print out something to show the user that you can print out error, something like, okay, cannot divide by 0 or something like that, because the user would have entered something that has a value of 0 here as the denominator. So you can say something like print error cannot divide by 0 to the output. So you can close this and this. Let's see. Okay, we're trying this and we're printing out the results to the screen if it works well. So let me save again and let me run if I'll still get my end of file error. Okay. The thing is actually maybe it's possibly expecting that I complete this statement since I've used the try block.
Yes.
I need to use the
That's true.
except.
That's true.
Like I said, these two guys, they work in pairs. They work hand in hand.
Yes.
Your try and your except. So I believe that's what it's expecting.
And I think you can also have multiple except block.
Yes.
That's multiple except block. As you did this except zero division error, you can also have another except. Maybe
Yes.
except type error, another
Yes.
except.
We can
value
have that.
error, as much as possible.
So this one is saying that enter the numerator, so we can just put in any value, let's say 100. Let's see if the program is working well first, then divided by the denominator is 5, then it's saying that the result is 20. So let me run the program again and let me now put something that has a value of 0 as the denominator, and let us see. It's saying that what error cannot divide by 0. So this except block is actually executing. But one thing to note is that my program did not crash. Unlike if I didn't have the except keyword, like what I'm saying is if I do not even have the I don't have this line, and I don't even have this line, and I don't have my try keyword here, then I don't also have my I only have these guys. I'm trying to print out the result, then I save my file, then I try to run it. It says enter the numerator, then I'm entering a value of 100 once again. Denominator I'm entering 5, then you can see it's working fine, right? Then I try to run it again, the same thing I pass in here 100, then I'm passing in 0, then I'm passing in 0, and you can see potentially it has terminated my program. You can see that, right? It says that what exception blah 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 0 division. This same guy, by default, my interpreter, my Python interpreter has called this exception. We're actually talking about what catching exception. So it has caught it that okay, I need you, please come up now and display this error message to the screen. So that is why it is displaying by default. This is an inbuilt exception. It is displaying this error message that division by 0 error. No, you can't divide by 0. And like I said, it terminated my program. Unlike here, that it's only telling me it cannot be divided by 0. Had it been I have a while loop or something like that, then my program will still run. But here, this is like an abrupt termination of my program, displaying an error message and my program being terminated completely. So we can use when we know how to control errors, we can use that to avoid our program crashing of our program and all that. So I'm going to delete this now. I'm going to delete this. I'm going to indent this again as we have it before. So except keywords can be used to invoke the error that we have. So this is it. If the try program, if the try code block actually checks through and no error has been encountered, then nothing will happen. Your interpreter is not going to come and invoke this 0 division or whatever error you have as in the except keyword. You can see what we have here. Our program runs just fine. 100, then 5. It didn't print out this error message to the screen because this error didn't occur. That is the 0 division error. What if I decide to use my program in another format? Let's say I have something like this, then I'm entering this again, enter numerator, then I'm passing in a value of 1 as a string, right? This is a string now. Then I enter this, then my program has crashed. Why? Because I didn't undo the error. You can see it's not even asking for my denominator, talk less of even dividing and printing out the result. So this is what happens when you do not undo errors in your program, because I didn't anticipate now that my user might likely enter a string, because here I did specify enter an integer value, right? and then the user entered a string and the program terminated instantly. Why? Because this error has been called. What's the name of the error now? We have value error. So to avoid our program being crashed, right, or our program crashing, what can we do? We just need to come and accept this guy. That is, we want to invoke this guy using the accept keyword. Okay, if this error occurs, this is what you should do. By default, it's going to just terminate your program, but now we are now saying, please don't terminate my program. This is what I want you to do. So once again, we are going to add more functionalities to this code, right? So how can we do that? Anyone? How can we catch this error? We are still talking about catching errors now, or catching exceptions. So how can we possibly catch this error that, you know, just terminated our program? I believe I'm still on the call, right?
Yes, you are. Yes, you are.
Okay.
Perfect.
Okay, I think Solomon was gonna be. All right. So how can I possibly catch this error so that my program won't crash?
I think you have to add another except block, except value error.
Exactly. So we have to use an except keyword again, right here, right? So I will say except, what's the name? Value. Let me just add a new line.
Value error. Value error.
Yeah, except value.
Value error. Error.
Then I'm printing it out to the screen. I can just print out, or you can even use the as keyword, except value error as maybe value, meaning that normally when you call an error, like here we call zero division error, ideally we do not put our print statement here. It will likely print out something like this. Where is it? Here, this one. It will just print out division by 0. So what we are trying to do here, the value error, I'm using the as keyword, meaning that whatever it is printing out to the screen, save it inside value. So I can just print value now, and then it will still bring out what it will normally bring out by default. That is the error message it will normally bring out when you invoke value error. So I can just do print then value, something like this. Yeah, something like this. Then I will save. Then I'm going to rerun or run this file. Then I'm going to pass in something other than an integer value. Then it's saying that what? Invalid. It's saying that invalid
for
literal
int.
for int with base 10.
For int.
Then it's displaying this guy. Now it is printing out invalid literal. Okay, let's see. Let me add to this. Let me say something like value error. Okay, let me use f string value error, something like this. I want to know the specific error message it is bringing out. Okay, so let me rerun my file and pass in something other than, what is it saying? It says that what? End of file, accept value as this, print value error. Okay, I didn't put the closing quotes. Okay, so I will run that. Let me clear my screen. Or no, because I want us to check and compare with what we have here. So I will still have this guy here. So I want to enter the same thing, 4, and then it says value error, right? Then invalid literal for int with base 4. So this is the same error message that our value error would print out to the screen. So I just put this here just to check. You can see right here we have it, invalid literal. So this is the value default message for value error. Then you can decide not to print out the default message, but if you want to print out the default message and also additional things or additional information you want to provide for the user, then you can just save whatever it is going to print out in a particular variable. Then you print out the variable in your print statement, then you can add additional information you so wish or you so desire to add for the user. So on and on, you can keep on catching different errors. So the point is, it won't make your program to terminate, or it won't make your program to stop abruptly. If you still want to print out something after this, it is still going to print out. Maybe after this your printed, maybe on line 17 you want to print out something to the screen, then there's a way you can still modify your program, so much so that your program can even continue running as if nothing has happened. It depends on what you want to do, and you also using the proper keywords to use. So now we've been able to see what we refer to as try keyword, and we've also been able to see what we refer to as except keyword. We use the try keyword, we place the block of code we want to run inside the try keyword, and our interpreter is going to run such statements that we have, or such a script. But we now use the except keyword to catch exceptions. Remember, it's the first thing we are discussing about tonight, right? We are catching exceptions. That is, whenever errors occur, runtime errors occur, then we can actually catch those errors and undo them as we so desire, so that our program will not abruptly end. So we've been able to see with this very basic code how we can undo errors using just those two keywords, the try and except. So moving on to the okay, there's still another error though. Let me turn this guy to a while loop, so it would keep on prompting me. I won't need to start running my file multiple times. So I can just say okay, I can just say something like while true, something like this. Then I'll have to indent this guy, then also this guy, and also am I indenting this one? Yeah, I'm indenting this one, this and this. Good. So I won't need to keep on recompiling and recompiling my code. Is it compile or keep reinterpreting? Sorry. I won't need to keep reinterpreting it. So this is it. Try this. Okay, now the error I want us to see now, I'm going to do that right here, so we catch that error too. So I'm going to rerun this code. Now enter numerator 1 2. You can see it's running multiple times, right? It keeps on running on and on. So if I want to terminate this program, I can use my Control D. I think Control D means end of file, right? So let me use Control D and let's see if it is going to get terminated. So I just use Control D. I just clicked on Control D on my keyboard right now, and then what happened to my program? Okay, I can see an error here again. It says EOF error, end of file. So I use Control D and then my program encountered an end of file error. But because I didn't actually make allowances for this particular error, like I said, errors can potentially terminate your program. My program was terminated without executing whatever I have. You can see it is asking me for numerator, and I pressed Control D. From line 7, my program terminated. But then I can still undo this error, which is the end of file, or in other words, they call it Control D. I can undo this error and modify it or change the behavior of this error. You know, this is what we are talking about now. You try to undo runtime errors, which we refer to as exception. So you can come here and decide to just say except, you know, just put in anything there, just type something there. You can type something like EOF error, then you can decide to print out something to the screen as well. They say something like, okay, you probably entered Control D or something like that. CTRL Control D entered. Yeah, you can use something like this, just so you tell the user, okay, you already entered Control D before it will get terminated to the screen. So you might decide to do something like this. then you run your program. Then I'm going to press Ctrl D. What is it saying? Oh, okay. When I type Ctrl D, it executed this except block. Then on getting to line 18, it says that what name error. It actually brought up name error because I use printf instead of print. I use printf in my code here, and then my code terminated. I believe we are still on the call.
Yes, yes.
Okay, you can see what happened there. I was actually raising an using I was trying to control an error, and at the point of controlling an error, I actually threw in another error. So I terminated. That's why the program crashed. Actually, the program crashed because I used a name that isn't defined in my code. So let me rerun this program and then enter a number 2 5 then 2, then using Ctrl D. Now you can see I use Ctrl D. Now my program didn't end. It says something like Ctrl D entered, then it started all over again. I use Ctrl D. I typed Ctrl D just now, unlike before when we didn't undo the end of file error, and then it crashed our program and our program stopped running. So you can use these errors basically when you accept errors, and you can use them to create even wonderful things, or you can modify the behavior or how your program behaves. You can use these errors to modify them. So moving on, because of our time and because of my battery percentage as well, let us stop catching errors at this point. The next keyword we'll be talking about is the else keyword. This guy, we use our else keyword whenever we want a statement to be executed after an error has been caught. Now this keyword is actually optional. The ones that are compulsory are this try block and the except block. These are the ones you might want to include, but you see these other ones, they are not compulsory, that you have to have them in your code. You can see even without having them, our code is still run, isn't it? So these ones are actually optional. It's an optional keyword. So we have the except block, and it will only be executed. Okay, you are saying something.
How about the raise? That's to raise the exception. It's not almost the same thing like the except. That can't you have try and raise instead of try except? Try, you put the block of code inside. Try, then
We are still going to get to this raise. Yes, it's possible. I understand what you are saying, that we should try and raise an exception. Yeah, that's possible. But this raise is actually very different from these other ones. Like, it's a special keyword from the other ones. These ones are used for catching, while raising an exception is actually different from catching an exception. I will still tell us the very little difference by the time we get to raising exceptions. So okay, we are talking about the else keyword that we can use. So you can say something like else, and I just print an error was encountered, something like this. So the else keyword will only be executed when an error has been encountered. That is, when at least one of these except keywords or except blocks were executed. If only the try block was executed, then our interpreter has no business with the except keyword. That is, if no error occurred. If this runs fine, that is, the user did not actually enter the wrong thing, or the user used the program the way we want them to use it, then our else block will not be triggered. But as long as any of these except blocks have been triggered, then else will also be triggered by default. So let us just show that and let us see. So I'm going to use my Ctrl D. Then my Ctrl D obviously is no more ending the program. So the next one I'm going to use is my Ctrl Z, that is going to terminate the process. So I'm going to rerun this program, enter numerator. I'm going to type in 1, then 2. 1 and 2, it says an error was encountered. Wow, our else block, sorry, I meant to say it will be executed only when no error has been executed. That is, if this block runs fine without the except keyword, then else will be executed. But if an error has been encountered, that is any of these guys, then this guy will not be executed. So let me try that again with an
So
error.
you can as well change it to an error wasn't encountered. Maybe you can change the string, the print string, to an
Yeah,
error wasn't encountered instead.
this
I
is
think
a
that
zero
that will make
division error.
sense.
Now our line 21 wasn't executed because an error has been caught. So that means your else block will only execute if no error has been caught. But if at least an error has been caught, then your else block will not execute. So I'm going to change that to an error was not encountered, like you said. Thank you for that. Um, so I'm going to use my Control Z to terminate that and rerun my program. Then 3 0, then it says cannot divide, then I'm entering a string, then it's saying string literal blah blah blah. But if I enter something that is correct, and then it's going to say an error was not encountered. So that's just basically all for else keyword, and you should only have one in your program. It's not that you have try else because we're having except. Then you can have multiple excepts, they are unlimited depending on whatever errors you want to actually check for. But the except keyword, you should only have one in your program, like basically just one in your program. Then the last one is what this guy called finally.
Else keyword you mean?
Yes, the else block. I
You are
didn't
talking
actually get
about
that.
we can have one except. I see whether it's the else block you are talking about. That we can have only one
Yes,
else in the try.
yes, I don't
Okay,
think we can
okay,
have more than one, but let me try sha.
okay,
I've not
fine.
tried that. Print.
It wouldn't make sense.
Yes,
Else, it doesn't make sense
else
to have more
what?
than one, sha, but just
Yeah,
let's see.
that's why I said there's no point having more than one, because even the interpreter will be confused. How many else statements do we have in our code? Yeah, it's saying that syntax error. It's saying syntax error in our code. So that is why this guy can't be executed. So let us go on to finally. Finally is just the very opposite of this guy. Else will be executed if no error has been encountered. Finally would be executed irregardless of either an error was encountered or not. Executed, or let's say always executed. Always executed. But this one we executed only when error free. That means this guy will be executed only if the program is running as expected. But this will be executed either an error was caught or not. Our finally keyword will be executed. So we can say, what can we even say? Okay, let's just say end of program. Let's just say end of program or something like this. So yeah. So let me try and rerun this code. Enter enumerator 1, then 2, okay, 1 3. Now this is our finally keyword. It was executed. Also our else keyword too was executed, like both were executed at once. Why? Because here we didn't encounter an error, that is for our else, and here irregardless of whether an error was encountered or caught, it's still going to run. So let me run this program now with an error. Oh wow, you can see I just typed in something gibberish here, and it's raised the value error, which is line 15. After raising that, it's printed out end of program, which is line 23. which is what the finally line 23, which is what the finally keyword is used to do. So majorly people use this finally keyword when you have something you must do, either an error was encountered or not. For instance, you are using your Python script to open a file. When you open a file, even if there was an error or anything, at times you might need to close that file that you opened, or maybe it's opened improperly, or whatever thing might happen. So most times they use it when they are handling files, or they are handling stuff that need to be always executed or always done, irrespective of whether we have an error or not while trying to perform the operation. Then that is all about the keywords that we would likely encounter, or these are just the basic ones anyways. These are the basic ones that would use when we are trying to actually catch exceptions. So this is how far we'll be able to go as per catching exceptions. So let us discuss briefly about raising exceptions.
The race, exactly, the race.
Now, when we are talking about raising exceptions, it is usually used explicitly. That is, this is you now trying to invoke or trying to call an error. Let me open my interpreter. So this is it. Now, we have a syntax error here. So you use the raise keyword, raise, then you just call the error. Nothing's happening, the error is on its own, but you want to invoke it, you want to raise it. Now remember, this is not runtime. This is just me trying to raise an error, just calling it out of the blues. Unlike the except that will only trigger when it is matching, that is, when the error occurs, then it will match it, then it will print out whatever code block we have there. But now when we are talking about raise, this is you trying to invoke the sleeping, how will I put it, the sleeping error. You just want to call it, okay, I need you, just come. So I'll just type that syntax, I'll make sure I get the spelling. So now when I type this raise syntax error and I press enter, then it's going to instantly trigger that. You can see syntax error. It's saying no detail available because I didn't pass in any, I believe, maybe argument or something to it. I can erase this syntax error and pass in an argument to it and specify, okay, I want you to print out something to the screen. I raise syntax error. No, I should terminate that. Can you see the syntax error, then the error message? So we use the raise keyword to explicitly invoke errors. You can raise as many as possible errors. You can raise the zero division, you can raise name error, you can raise anything you want to raise. Name error. Then it will give you the these errors are built in, right? And your interpreter can understand them. So let me raise name error on and on like that. Then it will tell you name error, I raised name error, and so on and so forth. So this is just the difference between you raising an error, that is, you are invoking the error manually, calling the error manually. Am I still on the call? Okay, it's still being recorded. Wow. I'm so sorry for that. This computer went to sleep abruptly. Which kind of error is this one? Which kind of error is this one?
I was supposed to see here. Okay, they've come back online. I think class they come. Maybe now we were part of the come out. They talk. I mean, who brought on the canopy? It never work. It never work. Why did you come and beat me? Why did you come and beat? Yes, I can hear you.
Can you hear me? Hello, can you hear me? Okay, yeah, you are muted, bro. But I believe you should be. Mr. John, okay, no problem. Thank you. I don't know, my computer went to sleep suddenly, and then it cancelled everything. But then my OBS is still working, so I believe I'm still live. All right. So I'm so sorry for that interruption. So we were talking. Please, can you help us, mate? Okay, thank you. So now let's talk into details what it means to raise errors. Like, let's discuss it into details now. I would want to open another file just to demonstrate that I want to open another file. I'm not going to try it inside this program, but please let us keep this to us, because I will still ask us a question that is still kind of related to this, about the difference between raising an error and using the try except to catch errors. Catching an error is different from raising an error. You can see I wrote it here, catching and raising. I'm still going to ask us like a question or two as regards that. So that's for that. Let me terminate this here. Good. So I'm going to.
So when is the best time to raise error? When is the best time to raise exception or to raise error?
Yeah. Okay. Good. You raise errors when you are so sure.
There must be a best case.
Raising of an error. This is you trying to raise the error when you are so sure. Okay, this is the particular error that is happening. But when you are using the try and except, you might not be sure if this error will work or not. You know, it is a try and error. You might raise, you might use your try and except, and one of the except will not work. Like this is it. As at the time of you using your try and except, you use the try, this one might check, this one might check, this one might check, or none of the three might even check. At the end of the day, maybe it is this that we check and maybe this that we check as well. So when you are using your try and except, you do not necessarily know when exactly these guys will check. But when you are using your raise, this is you as user. You know, okay, maybe a 0 division error is going to happen depending on the way you wrote your code. Okay, let me write something that is related to that, and we use the same error again. The 0 division error. We'll deliberately invoke it.
See, if you are sure of a particular error, that a particular error will come out,
yes,
then why raise the error? The error is, why calling the error when the error still come on its own? If I'm sure a 0 exception, a 0 division error will occur as an exception. Instead of raising the 0 division error,
okay,
so instead of call it by using raise, yes, why not catch it? If I'm sure that a particular exception will occur, I rather catch it than raise it, because it's going to come in ways.
It's going to see translate to the same thing, but
it's not going to come. I was just want to call it.
Well,
it's because it's looking somehow.
There are times
it's not still going to come. Why keep calling it?
Do you know if it comes by itself?
Without you,
if it comes by itself, let's see. Let me try to. I feel if an error comes by itself, by default, it's going to terminate your program. But if you raise the error manually, then probably it will not crash or terminate your program, possibly. But what I'm so sure of is when you use your try and except, your program won't crash. It won't crash. It will still run smoothly, unless you didn't catch an error or maybe any other error, then it's going to terminate your program. But if you deliberately raise an error, this is you manually trying to raise the error, then that means you are so sure the error is coming and you would raise it, maybe using an if else condition or something. Yeah, you can raise errors in numerous instances. One way is through your if else block, another way is through try and except statements too. Like inside this try and except, you can raise an error too inside it. Like for instance, the other time that I used my printf, you can see that I used printf here, it was raising a syntax error inside end of file error. So you can still raise an error here. So we've been able to see on our interpreter how you can just
you can call
raise errors.
a wrong error.
You can what?
You can call a wrong error now inside the
I can
you
call
call a wrong error. Thank you.
a wrong
It's
one.
like a wrong error. For instance, if there's a value error, yes. For instance, if there's a value error now, and you want to catch it, instead of I say I try the code now, I catch the value error. That's except value error. Then
Yes.
what I run inside the except block value error is I now call and now raise type error. So
Yes.
instead of print something, you get try this thing now.
I get
Except value error. Then
Like
instead
inside-
of doing print, instead of printing something, I now raise
Raise an error.
type error. That means type error will now come out. Yes, type error will now come out. instead
Where
of,
value error is
I
supposed
don't
to
know
come
that
out.
it works like that. No, because this thing cannot confuse the user. You will not be getting excuse me, a
Another
wrong,
error
this thing,
inside
signal.
another error.
I don't know. That's why I'm thinking whether it will work like that.
Yeah,
Like that thing might
possibly.
still work. Because you can do me like you can raise the exception where you're not supposed to raise it, it will not work. And the user will not see a different error than the one that's supposed to come out. And if it's a novice, the person will not know.
But
not get it wrong
I
with
feel someone would not want to do that. Like you raising an error without.
I know. Yes. I know somebody wouldn't want to do that. That's
Yes.
a professional or an advanced person. But it's a possibility. Now Python has left this
Yes,
possibility.
yes,
So
I believe it's
one
a
thing about
possibility.
leaving this possibility to the programmers, to the users,
Yeah.
you will likely going to encounter these exceptions or these things. Because if
Yes.
you give power to somebody, expect the person to use the power anyhow.
Yes.
And if you don't
Yes.
want the person to use anyhow, then you remove the power from the person. And that's the thing. So Python has given us a new problem
The
by
ability.
giving us the power to call error. That means yes, the ability. So we can call it anywhere we want. It doesn't. That means we can create a problem out of it.
Yes.
That's,
So I want
that's
to.
what I'm saying. That's what I'm saying.
Yeah, I
Don't
agree
need
with
to-
you. That should be possible. You raising an exception inside another exception block. You raising an error or an exception inside an exception block. I so much agree that is possible. So I want to just do something. I still want to use the. Okay, I should use another error now. I will just raise an error, and let's say I want to raise the value error. Yeah. Let's say I want to raise value error. Let me see. Do we have value error here? Syntax, name, value. We don't have value error here. Okay, let me raise value error. Let's see. Raise value error. Value error. Okay, yeah, there's an error called value error. Now I want to check if this guy is positive. Maybe the user will enter a value, and I'm now going to use my if condition. If value is less than 0, then I will now use my keyword raise value error. So this is one way you can, like I said, you can raise value error, you can raise errors inside if block or your else or whatever, like on and on like that, depending on whatever you want to write. Then you can also raise them inside your try except too, and other instances too. I'm not saying these are the only two instances where you can raise them. I'm only saying it can be done in your if block, and it can be done in your try and except block as well. So we are saying that if value is less than 0, then it should just raise this error. Now by default, this is how you write your value. This is how you raise errors. You type in, let me put a comment here. at the top here, or no, let me put the comments here. You type in the raise keyword, then you also type in the exception type, you so desire to raise, that is, you are invoking it manually. Then you type in the error message you want to print out to the console. Then when you do this, this is the basic way to raise an error. You use your raise keyword, you type in the name of the exception. In this case, we are using value error. That is, we are trying to check if the value the user is going to enter to this function. This is just a demonstration though, it's not actually practical right now. So I want to raise that error, that okay, it is going to print out an error message. So I can just print out my error message, enter a positive value, something like this. I just say enter a positive value, on and on like that. Then I can go ahead to just call this function. Okay, I can decide to even print out the value. That's if it happens to be a positive value. I can go ahead to print it out. Then I can just call this guy called positive and pass in a number to it. Let's say I want to pass in 1. Let's just do this. So let me save this file. I believe I'm still on the call. Okay, so I want to save this guy. What's the name of this guy? Raise.py. So I want to run this guy, python 3 raise.py. Then it's printing out 1. Now let me pass in a negative value. I want to pass in -1, and I'm going to save again, and I'm going to rerun. Then it's actually throwing this error that we manually by ourselves we raise this error, but inside an if block. That is, if the value is this, then you want to raise this error. Now in this case, this of course can still be done with your try.
Did the program actually crash after raising the error? No, after raising this error, did the program crash? Because I'm not sure again when the program crashes.
Let me see. Did the program crash? It printed this blah blah blah. Yes, the program crashed.
Yeah. Okay, that means when we call any exception, when we call an error, it will crash.
We raised this error and it crashed.
So you are saying that when you if you come to the point, it crash.
Yes, it crashed. Now, which now begs the question. You know, I said that.
How about raising the error and catching the error? How about raising the error and catching it?
So and catching it, yes.
You finish raising the value, yes.
That's the question I want to ask. That is it possible for us to catch this error?
Except value.
So how can we do this?
Python don't give people power. No wonder Python is doing.
How can I modify this code in such a way that it is going to raise this value error, and I'm still going to run my code successfully? How can I do that?
So after the raise,
I want to raise this value error.
You now come and catch it. Except.
Come again.
After raising the value error now, I mean after raising the value error.
Okay.
That this raise value error, you now go the next thing now you catch it, and you now instead of print value. Instead of print, okay, raise value. You didn't do raise value error as value.
You know you can't raise
and catch. That.
To catch errors.
You did raise value error.
To catch errors, we use the try keyword and except now. I said these two words they are very different from raise.
Don't use try and raise. We use try. Don't you try a block of code? Well, after trying a block of code, you raise an exception, you raise an error. Then you now still catch the error. And possibly catch other exceptions.
This is what I'm saying.
How should I modify this code? You now still catch this value error.
How should I modify this code?
How you should modify it to do?
Yes.
Modify it for what exactly?
In such a way that this my function, I will call it, and if I enter -1, it's still going to run. It will not crash like this. And I want to have my raise value error inside this place and my function will not crash. Yeah, on raising the error,
without
program
using try,
terminated.
without try. I mean, yes, without using try,
No,
try
we can use it now, of course, but I still want to use the keyword raise in my program.
No, I mean, like this. Do you want to do it like this? Do you want to do it like this without try except, without using try except?
It's not possible. You have to use try except to run your code.
Oh, no. Okay. That's what I was asking now, because
Yes.
ALX always give you condition.
No.
Without using this.
To the best of my knowledge, I don't think you can raise an error, and if the error has been caught, your program will still continue running. I don't think. For now, I don't know. Maybe it's possible, but I actually don't know.
Okay. Then I think we should. Then I think we should try. In that case, now we should try the condition. We should try the if value, if condition. Then we raise the value error. We still catch the value error.
Okay.
Probably we can catch other errors too.
Okay.
Other
What if we do it like
as
this?
we raise the value error, we must catch the value error.
Let me open this file again.
After raising, you catch it. You try.
And let us see. What if you can see here, I said the other time, I said try is used when you have a block of code that can potentially have an error or might raise exceptions. Now the question is this: what in this code can raise exceptions? That's the first question. What in this code can raise an exception? Can you hear me?
Yes.
So what in this code?
Okay. What can raise an exception?
Yes.
What can raise an exception? Let me think of something. Okay, when a value is not passed into the function, the positive function, that's an argument was not passed in the first place. They say if value is less than 0, it's checking the value. But what
So
if there is no value
possible
at all?
if you do
For you
not
to
raise.
check. No, there's the condition.
Okay. Now, our try block here.
There was no argument at all.
This is it.
Then secondly, if the argument is not an integer, you not say if value less than 0. What if the value that the argument is not an integer?
Maybe we pass in a string or anything. That's another error.
And it's not a float. It's an int. Yes, it's string or int. Yes.
That's another error. Now,
Hope I'm correct.
yes, you are correct. The point is this program will crash as at this point. We are calling the function here. So the interpreter will read this first line. Then on getting to, if this condition is true, then it's going to come here and execute this line 4. Then it is going to crash. The question is this: where am I calling this program? It is at this point, line 7. On getting to line 7, it will now start at the top and starts interpreting whatever we have inside this program. What if we put this guy itself? Because try is used for code that can potentially raise an exception. Where will this exception be invoked? It is when we call this function, which is on line 7. So if I put this guy himself, this line 7, I put the function inside the try except, meaning that try this function. If you now see an error, then we now use except keyword for this function itself. We do not necessarily need to come and raise the try except inside the function declaration itself. So basically it's just we saying on line 6 try, then we now pass a function here, then except, then whatever error the function is doing. So basically you can just erase whatever we have on lines
I get your point.
7 to 11.
I get your point too.
Yeah.
So, okay. But see it this way.
Okay.
What if somebody imports this module? What's the name of the module now?
What's the
Yeah, this positive function is. What if let's say the name is exception.py.
Okay.
That's the name of this module now. This
yes.
Let's say it's exception.py.
Okay.
And I didn't say import exception. I didn't say import exception.py. Well, I say from exception.py import
Yes.
positive.
Mm-hmm.
Now it's going to import this function positive
Mm-hmm.
here,
Mm-hmm.
and only the function, and the try block is outside the function.
Yeah.
So when it imports that positive, and I
Yeah.
now go and call the function and pass in a negative value, it will still crash now because
Yes.
this try block is outside the
It's
function.
outside. Yes.
You get it? It will still
Mm.
crash.
You are
So
talking about
you have to
if we
anticipate
are
where
trying to import
somebody
this
how
guy now.
somebody is calling.
Okay, I get your point. So
Except they import the whole module. But if you import the function from the module, it will still crash because the try was not inside the function.
yeah. So what you are saying
This
is
is a
this:
factor of safety.
we do this right. We try this, then we now
Yes.
use except keyword inside this function itself, like this,
Yes.
right?
After raising. Yes.
After
After
raising,
raising the. Yes. You know, accept.
so
Yes.
we raise a value error. Then on getting to value error, then we should now say except. Then we call it again. Let's see,
You can.
like this, ba?
This except is general. Okay. So, it's not value
Or I
error.
use
Yes.
else.
Value
Should
error.
I use else? Since we know,
No.
okay,
No.
it's surely going to catch an error. We can use finally here, sef.
No. You don't need to do else. Yes.
Finally,
No.
because
Finally.
yes,
Finally.
finally will be
Finally. After
executed.
it has crashed.
Huh? No, finally will
Is
always be
this
executed.
wait? The finally now.
Uh-huh.
Remember that this even after the program crashes.
Finally will always be executed.
I know finally is supposed to always be executed, but
Uh, no, if we are using try except, I don't think the program will crash again.
no. No, look at now. We have not used except. You did try. You raised value error. Now you have not done except. You have not caught the value error.
Okay.
Try to catch the value error with except. If not,
Let's
if you
see.
say finally, I'm not sure it will crash before the finally.
Okay. Let's do something like this.
Except value error. After that one, the finally can now work. After you write something, whatever, finally can now work.
We
But
can
trying
now
to
call
catch,
finally.
trying to catch.
Let me just maybe print.
Or value, I said value. I mean, you can pass. Now you can make it
Try.
to face silent.
Huh?
Or you print something. I don't know.
Yeah. Just to be sure it's actually catching it.
I don't know how it will be to face silent. Okay. Fair enough.
Okay. I would love to try this out. So we are doing try this in our code. If value is less than 0, then if it fails, except value error, print. Now, you know we are hard coding this. I would have loved it if we used the input keyword, but then it's still going to raise it. So if value is less than 0, do this, then except print trying out, then finally, okay, let me say finally should print out value, something like this. Should print out value. Okay, so let us try to run this code and let us see what will happen. So this is raise.py. okay, and then it printed out trying out, then it printed out value. Did it raise the value error? Our value error wasn't raised, of which value is actually less than so I try running that again.
You raise the value error now. But you see, you printed trying out. Look at now the except keyword. You raise the value error with except
Then
keyword.
it printed out the except
And the
keyword.
value error to print trying out. So you printed trying out. So it raised the error actually.
No,
Then finally,
but
now
it
printed the
didn't
value,
print
which
out
is
this error message. It did raise value error here.
No.
It raised value error here, but that means this word
I'm not sure.
raise value error. Let's say we do not have except keyword here. Let me see something. Let's see what will likely happen. Okay, I should actually have this here. So let me delete this guy. Okay, so we are trying to use the finally keyword without except if we are going to get a syntax error. Okay, we have value error. What happened? Good. So it's raised the value error and it also executed the finally keyword. So the finally keyword was executed first, which is this guy. Then thereafter it raised the value error and it printed out this error message called enter a positive value. Then it terminated. That means normally it's supposed to raise this guy first and end the program, but then it came here to execute the rest of the code, then it executed this one last and ended the program. Did you see what happened there from here?
Okay. Okay, print.
It executed finally because we said finally we
Where
always
did it
execute.
print the?
Then it did raise the value error.
Did it finally print value?
Yes, just print out the value that is -1. That's what is there. Just print it out.
It did not print. It did not print it now.
This is it. It printed it at the top.
Look at it. It did not print the -1.
This is it now.
Okay.
You know,
before the error,
if it raises an error, it is going to crash. But this except keyword will not allow it to crash. So when you invoke a program, when you raise an error, it is going to crash. But it is the except keyword that will not allow it to crash. But then we are now saying raise the error and I want you to run this. So it can't raise an error and still run at the same time. So it has to run first, then now come and raise the error. So that was what it did. If it were to raise an error first, then it's going to crash.
Okay.
But except we use the except keyword, which you said we should do, and then it worked. You know, so it ran fine. Using the except keyword, it's just going to print out. That means we should have used this. We should have just entered this error message. Enter a positive value. We just put that here. Then it's still going to work fine. Try enter a positive value. Okay, you know what? Yeah, let me say raise 0 division, which is even the wrong type of error. Let's just see what will happen. You understand? Like we are raising value error here, and I'm saying except 0 division. I want to see if it was the value error that was entered here that actually got triggered when we use the except value error. So let's just try this and let me see if the program will run or it will eventually crash. What just happened here? So it says that what file raise.py raise value error enter a positive error. Then it says okay, no, this is it. Line 7. Okay, our interpreter is complaining about line 7. What did it say? Except I think it's complaining about indentation does not match outer indentation. Okay, I think I didn't indent properly.
It's true.
I didn't indent properly. Okay. Okay, let me rerun this. Okay, it ran fine. Trace back, which is this guy. So the first thing it executed was the finally keyword, which is my -1. Then on doing that, it raised the line 13 line 13, okay. Raise value error, enter a positive value. Which is this error? It raised this error, then after raising this error, the program terminated. So our line 11 was executed first, then it went back to execute this error, to raise this keyword. That means on getting to line 2, when this condition checked, then it raised the value error, but because it is going to terminate the program and we still have a finally keyword here, so it has to just wait for this guy. It has to just execute finally first, and after executing finally, it came here to execute this line. So that means if I should delete finally keyword, it's just going to raise value error and the program will terminate, like the way it behaved earlier. That is what is going to happen. So moving on, I don't know if we have any questions as regards this about how our raising of errors can wait for the finally keyword to be executed before it's now going to raise an error that can potentially terminate the program. So what's the
I don't know,
third thing?
sure, but
Okay, you have a
it's just
question.
the way the finally works. The way the finally works is the concept is clear, but
Yes.
I don't know if I'm not trying to imagine how the interpreter is actually doing it. Because is it that it checks if there's an error first before deciding to call finally before the error, or what? Because the error actually came before the finally
I think it's checking the keywords.
code. So I'm
Try,
just wondering how the interpreter
except,
actually.
and finally. I think it's checking only the
You know,
keywords.
after checking try, except and finally.
Yeah.
No,
Then
get my point. It has checked try, it has checked except, it has checked finally.
yes.
You
And
know, this
what the
finally, it's only when there's an exception that the finally comes first. If not, the finally will come last. So I'm wondering whether the interpreter checks whether the exception really happened. Not just keyword, whether it checks whether there was actually an error. That instead of printing executing the error, to execute finally first. I don't know. It's
okay,
just,
you are saying if the
I don't try
interpreter
to imagine
checks,
how the interpreter is doing it.
if the interpreter checks line 5,
If there's, if, no, see, the interpreter checks line 5.
yes,
It has raised the error, yes.
value error, yes.
But does the interpreter check? You know, this raise keyword is optional.
Yes, yes.
Excuse me. What I'm saying is that it's optional, so you could as well have removed it or commented it out. So
Yes.
there will be no error at all.
Yes.
In that case, the final print will be the last thing to be called.
Yes.
But does the interpreter actually check if there is actually an exception to crash it? Then instead of executing the exception, I believe everything is a function. I believe that error, this is a function that executes and crashes. But so I'll say whether it checks whether that thing is available. That if there is an error, instead of executing the error, it will call the finally first before executing the error, which is to print the error message and crash the program. I don't know that you get. I'm not trying to
I still don't get the question.
figure
Though.
out the possibility.
But what I do
No,
know,
you try after trying this block of code, you raised an exception.
yes,
You raised an exception.
yes,
Now, this exception now is supposed to crash the code when it's called. But for adventure, there was no exception raised, or there was no exception encountered. The code will not crash.
Yes.
Or in case the exception was handled with except, the code will not crash. Then finally will be called later after all this, after the whole
Yes.
exception, after the exception
Yes.
has been handled. The last thing that happens finally. But in case the exception was encountered for it to crash and the exception was not handled, I noticed that the finally was called first before the exception occurred and crashed.
yes,
That's what I'm asking. Is it that the interpreter will check if an exception occurred and was not handled instead
Yes.
of executing the error message, which is to print the error message and crash the program? It will call finally first. before. I believe that is the function that
Okay,
shows you the error message and crashes the program
let us do
simultaneously,
this.
sequentially.
Let us
I
do
believe
this.
it's a function that does that. I'm just trying to imagine how they created this thing.
Let us use else just to see the flow of execution. Okay, let me run again. Oh, what did I type there? So let me run it again. The first thing that it is printed was value. It printed value again. Then after doing that, let's see. Then it raised the exception, which is this guy. In fact, it didn't even execute the else statement. No error occurred. And remember, let's see what we said about, I think this is another, for else it says that executed only when error free, meaning that if the try block runs fine, then else will be executed. Now at this point, this ran fine and this worked, but this our else statement wasn't executed, meaning an error was encountered. So the error inside this place. So maybe it is this error now that is affecting our else statement not to be executed, because else will execute if no error was encountered, and yet we're having an error inside our if, or should I say inside our try block. We actually encountered an error. Now if we remove this else and even this except, and we're only running our try and finally will be executed, then this try would be executed. But in a normal situation, try should be executed first. But the reason why it is not following the proper ordering is because if you raise this value error, it is going to terminate your program, and if your program terminates, then this finally will not be executed. So it has to execute finally before it will come here and finally terminate the program, which is what we have here. So it is executing finally first, then it is now raising the value error, which is this guy, value error, enter a positive value. But if we do not want this to terminate, then we have to use the except keyword, and we have to make sure it catches the error itself. So that means if I come here and specify value error, then my program will not terminate. Value error, something like this. Then I try to run my program again, then it will now run normally. It says enter a positive value, which is what? My error, value error, which I raised here inside my if condition to show that it has been caught. You raise value error, but this value error is supposed to end your program, but it sees that the exception has already been raised. Then your program is going to run fine because you already raised the error, meaning that something is catching this error. That's why I said by default, if an error were to be raised without nothing catching it, it's going to terminate the program. But because something is catching this error, so this is what will be printed. You raise the error manually, but then you are still catching the error using the except keyword. Then you have your else, which will not be executed in this case since an error has been caught. Then your finally would always be executed irrespective of whether an error has been caught or not. I don't know if you understand the analogy I did just now about you catching an error. If you do not catch the error, it's going to terminate your program. Either you raise it by yourself or your interpreter raises the error for you. If you do not catch an error, your program will crash. But the only thing that won't crash your program is if you have made allowances for the particular error, then your program will run fine. I feel that is what is happening. And mainly because we do not catch the error, that is why our finally block was executed before it decided to come here to crash the program, which is what can account for.
That's what I was asking. That's what I was asking. Because finally it's always coming last.
It's always coming last.
But yes, in case there's an error, it's not. Yes, but in case there's an error, there's an exception that was not handled. there was no
Yes.
cut. It will now come first.
It will
So
now come
it's
first.
looking to me, from all the experience of programming
Eh.
since C, and yes, since the beginning of experience one till now, it's looking like it. I'm just imagining myself as the person that develops Python interpreter. Excuse me, whether to check if while executing to now check if there is actually an exception occur, and there is a this is finally block. That in that situation, it will now raise the call the finally
Finally
first.
first. Yeah.
Before it will now invoke.
The execution.
Yeah, before it will invoke, it will check the condition. That's what I'm saying.
Yes.
I'm just trying to imagine myself. I know it's a bit beyond scope. It's part of understanding.
There's still one thing.
And it's making me now to see this error message as a function. It's making me to see this error message as a function.
No, these errors,
they
actually
did, simple share to
the errors are classes. So
a function that
yeah,
the classes has method now. What I'm saying is that as it invokes the error message, it prints the error message to standard output and it terminates the program.
Yes.
It terminates the program. So two things happen, which looks like a function. A function is printing it out, is doing something, terminating the program. So yes, action. So
exited.
Obviously, it's a function. Yes, and terminated. So the process of getting an error to show you and terminating it, I believe it's inside the same function block. I'm just imagining, we did a printf. Imagine they say you should do, sorry, not a simple share. Imagine they say you should not do simple share project. You should do Python interpreter in place of simple share. I'm just imagining I would have actually done it.
That's something like
to help us understand. Sorry, I hope I'm not going over syllabus, but I'm trying to. I'm just trying to understand the whole process. Because if you understand how the interpreter works or compiler works, you will never be getting it.
There's always something
because you are the interpreter or compiler itself. You'll be reasoning like it, yes. You'll be reasoning like it. So that's what I'm just trying to.
Yeah.
That's what I'm just trying to wrap my head over.
So this finally was executed, right? Now, I want to do something. Let me remove the while loop just to check how this finally works properly. So I want to enter an error here that we wouldn't catch. I want to see if my finally will be printed. It will be executed before the error will terminate my program. So let me remove this zero division error.
We have almost finished. We are about to finish. We are about to round up.
So I just removed my zero division error. Yeah.
Yes,
so Python 3, then exception. It's saying unexpected indent on try. Oh. Let me just put back the while true because I can't start removing all the so let me just run that. Enter the numerator. So I want to enter 200, then I want to invoke this guy which I didn't catch, so let me pass in 0. So I want to see if the program will terminate or it will execute finally then terminate. I still don't know if this while true will influence the behavior of the program though. So let me see what would happen. And then interesting. Can you see what happened? We didn't catch our zero division error. Then it's printed out end of program. Our finally block was executed instantly and our zero division error crashed the program. Can you see that?
Yes.
Our zero division error crashed the program. So it translates to we saying if this guy denominator equals 0, meaning that inside our try block we are writing something like if denominator equals 0, then raise zero division error. Is the same thing as we doing that without catching the error. So if we raise zero division error, it's going to come and execute finally first, then it's going to crash our program. You get the gist? So basically, if you are raising an error, accept the error too. That is, you raise an error inside your try except how will I put it? keyword, but you can manually invoke the error since you already know, okay, this error must be invoked. That is, we are saying if, where is it, you are writing something like if denominator equals 0. Is this correct in Python? Then raise 0 division error.
Honestly, that looks like redundancy. That looks like redundancy because without the if statement, if you zero error will still be raised. We still call. So why raising
Exactly.
it manually
It
when
will,
it's already
it will
coming
still be,
automatically?
it will
The
be
thing is still
invoked.
coming, so it's redundancy. It's redundancy. So
It's
it's already
inbuilt.
the if before the if statement even runs, everything is already coming. Yes, so it's just redundancy.
So if you do if here, then you can catch it here and blah 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 blah. So basically you can raise an exception manually by yourself and you pass in your error message that you want to pass into the exception. Then the last thing I would want us to talk about is briefly is built-in. I think our time is fast spent, so just talk about built-ins. Okay, our time will not allow us to talk about that, so maybe we just go and read up about that. At the end of this beginning of this session, we talked about two types of errors. We talked about the built-in errors and also the user-defined. Oh, I said built-in, user-defined error, where you can define your own error and you can invoke the error. And like I said, all errors are classes, and the master class of all errors is the base exception. The base exception error. All other errors are actually subclasses to that error, the base exception error. So you can define your own error and you can call it in your program. When you want to define your own error, you use the keyword, your error name, then you pass in exception inside it. So you can just say class my error, something like this, then you pass in exception keyword. When you pass in exception keyword, okay, it should be in caps because it's not color coded. When you pass in exception keyword, you can see now it's color coded. My error is going to actually inherit all the attributes of exception, like this, the built-ins we have in Python. Is going to inherit them, and there are some built-in, what do we call it now, methods or properties that you can use. For instance, traceback, something like this, traceback most recent call. This one in itself, this traceback is an attribute. So when I define my own custom defined error, it's going to, by default, it's going to have this attribute called traceback. It's going to have attributes like, if you want to print out the name, the class attributes, and so on. So basically, when you define your own custom defined exception, it can behave like the built-ins we have in Python, and it can do a lot of beautiful things with your custom defined. But this is the basic syntax. Your class keyword, then you pass in the exception keyword so that it can inherit all the properties of this class called exception. Then you can now write your block of code, whatever you want your exception to do, whatever you want it to raise, if it's the value error, and so on and so forth. You can define what you want it to do. So thank you very much.
So how do you call it now? How do you call it?
Yeah,